All right, welcome everyone, and thanks for coming out today. I appreciate it. We'll give it another minute or so as we're seeing some participants trickling in, but I really do appreciate you all taking the time to come out here today and spend a little bit of time with me going over some new features in the Tidy Census package that I'm particularly excited about. So first and foremost, I am going to paste some materials in the chat for you. And so this will allow you to, at your leisure, try out some of the examples that I'm covering. And something that I will be keeping an eye on, and I'll probably try to present for around the first 50 minutes or so, is the Q&A. I'll have that up and the chat. So feel free to pop anything into the chat that you need, ask any Q&A. I will keep an eye on that. So to get started, what I do want to share with you is a couple links, and those are going to be pasted here into the chat. So first, I am linking you to the slides. So if you go into the chat, what you're going to see are the slides for the presentation. And basically what that will allow you to do is flip through exactly what I'm flipping through. And there are going to be little code samples that you can try out yourself on your own computers. So you'll be able to kind of run everything that way, so long as you follow the instructions. The other bit that I want to do, and I'm going to paste this over for you as well, is I want to give you a link to the GitHub repository for the webinar. And so that's pasted into the chat now as well. So you should be able to see that. What that will take you to, and I'll just go ahead and move that over just very briefly, is for those of you who have used GitHub before, this should be something that is familiar. You can go ahead and clone the repository. If you're not familiar with GitHub, this is the file that you want, index.qmd. That is the Quarto source for this presentation. And I think that's interesting and useful for a couple of reasons. One is you can learn how to build a Quarto presentation. Quarto's interface to the reveal.js slide deck engine is really, really good. It's the best HTML slide generator I have ever used. And I'm using it here for this presentation. Try building those slides yourselves on your own computer, and you can learn a little bit that way. Additionally, you can go through and open that in RStudio, and you can run some of the code yourself. So you'll have those opportunities to stay on top of things, try things out, make some modifications. All right, with that in mind, what I'm going to go ahead and do is jump back to the slides here, and we can get back into it. All right, so first things first, I do want to highlight some opportunities for additional GIS training. So, I've launched a new initiative in my business offering data science workshops. I had a couple very successful workshops over the summer where we covered new features in Tidy Census to work with the new demographic and housing characteristics file. And so I'm offering a couple new workshops in October that I'm really excited about. I've gotten a lot of feedback from the community about this. And so I'm going to be sharing a lot of tricks and tips that I've learned along the way. And I would love to have many of you there. And so for coming out today, I'm giving 25% off these workshops. So the first one here is getting started with geographic information systems in R. You can read about that from the link. I'm going to pop that in the chat as well. You're welcome to take a look at it. And feel free to go in, use the discount code DDHC-A, and that'll get you 25% off. And so that's at 11 a.m. Central Time on October 4th, so that's next Wednesday. The second one, I'm really excited about this one, is interactive mapping with R. We're going to cover everything from how to customize maps with MapView to create really sophisticated maps with a lot of data and use some of my favorite R packages like ggiraffe to create presentation-ready interactive maps. And so I'll pop that link into the chat as well. That 25% discount for coming out today still applies. And then if you'd like to get some additional training, you can visit my workshops page here. It's at walker-data.com/workshops.html. I'll go ahead and paste that into the chat as well. You can get a feel for some of the things that I'm working on and offering. And what you can do is I post recorded workshops there. So recorded workshops from last summer, you can go in, you can register for the upcoming workshops, and you can take a look at some of my past workshops on 2020 census data. So, a few things that we can do that you might be interested in taking a look at. All right, so definitely appreciate you considering that. Would love to see many of you there. And that 25% discount code is going to be good for you all the way up until the workshops start. All right, so a little bit about me. You may have some familiarity with me if you have used the tidycensus package before. If not, and you're just kind of hearing about this, want to dip your toes in. So I wear a variety of hats. I chair the geography department at TCU in Fort Worth, and also work pretty extensively as a spatial data science consultant in a variety of different verticals. You may know me as a developer, again, of the tidycensus package. I've developed a few other R packages and a Python package as well. And I have a book, Analyzing US Census Data, that was published in February of this year. It's free to read online. It will always be free to read online. But certainly if you'd like a hard copy, you can find it on Amazon and a variety of other places. And to get started, so coming in, given we only have an hour, I'm not going to be going over how to get set up with R, how to get set up with RStudio. One thing I do tend to recommend, if you are brand new to R, if you've never used RStudio before, visit the website posit.cloud. So if you go to that website, posit.cloud, you can get access to a free online version of R and RStudio. And so I'll go ahead and paste that into the chat. And you can log in and authenticate with your Google account if you want to, or you can just set up an account that will create in RStudio in your browser, and you can run this code there. And so give that a try if you're brand new to some of these topics. If you're more experienced with these topics, you should be able to run all this code on your own computer, and it should be good to go. All right, so jumping back to the slides here, and this is very important. So these are some brand new features in tidycensus that I'm covering, and I had to spend a fair amount of time and do even a little refactoring to get some of these data sets to work. So you're going to want to make sure that you have the latest version of tidycensus and the latest version of the Tigris package, which is the geometry engine that tidycensus uses to get spatial data. You'll also want the map view package. I'm not doing anything incredibly sophisticated with visualization in today's webinar, but I really like the map view package for interactive viewing of spatial data and interactive maps. And so I will be using that today. So you're going to need those packages. Again, tidycensus 1.5 was released a couple days ago on CRAN, so you may not have it. So even if you're an experienced tidycensus user, please make sure that you have the latest version of the package installed, and you'll be good to go. Same with Tigris. Tigris has a much more minor modification in it, but it is an important modification that allows you to do some of the mapping that is in this slide deck. So if you're following along today, make sure that you go ahead and do that right now. If you're planning to try this stuff out later, feel free to grab that a little bit later on. So let's dive in. Today, I'll be covering new features in tidycensus that focus on two very important brand new data sets that were released this month by the US Census Bureau. The first is the 2022 one-year American Community Survey. And the 1-year ACS is one of my favorite data sets because everyone is always trying to get good data that is as up to date as possible. And it's very, very hard to do that. I mean, it's very difficult to collect data in real time and represent that data in a way that is correct and consistent. But when the 1-year ACS comes out, we're dealing with a temporal lag at this point of only about a year. And so this gives us right now about as up to date of demographics as we can get. Because again, if you're buying from a vendor, they're likely modeling data based on the ACS or other sources. And so this gets you about as close as you can. And allows us to look at some pretty interesting insights, especially post-pandemic, about the US population. I'm going to spend some time going over the American Community Survey and then some things you really need to know about when it comes to the ACS. And so just for starters, what is the ACS exactly? So it's an annual survey of about 3.5 million households, as opposed to the decennial census, which we'll talk about a little bit later, which is intended to be a complete enumeration of the US population. The American Community Survey is, in fact, a survey. And what it gets you is information about topics that aren't covered in the decennial census. So income, education, housing characteristics, language, industry, occupation, many, many more topics than that. The ACS is going to be the first place that you want to go for the best and most comprehensive public data on these detailed characteristics of the US population. So the American Community Survey then is conducted annually throughout the year, and then it's released in 2 flavors. The 1-year American Community Survey is what we're covering today. That's where you get the ACS for a single year, but you only get it for geographies of population 65,000 and greater, which is an important characteristic that we're going to be digging into in just a moment. The other type of ACS data is the 5-year ACS data. And the 5-year ACS data is a moving average over a 5-year period that, say, will cover the most recent data we have is 2017 to 2021. So all of that information is used to develop the estimates. And that goes all the way down to the block group level, which are census geographies of about 800, 1,000 or so people. Importantly, when you're working with ACS data, and we'll engage with this a little bit, what you get back are estimates, not exact counts, but rather estimates characterized by a margin of error. And so we'll engage with that a little bit more and how that matters for the American Community Survey in just a moment. And so moving ahead here, I want to just talk a little bit about working with ACS data in tidycensus and how you do that sort of thing. And so this may be review for those of you who are more experienced with tidycensus. If you're brand new, my book is a great place to get started. My workshops are a great place to get started. But you also can try out some basic stuff here. So the required arguments in this get ACS function, that's your portal to the ACS and tidycensus, are geography and variables. So you specify a geography. In this case, we say tract for census tract. And then you specify one or more census variable IDs, which I'll talk more about in just a moment. That will get you back data. For census tracts, we want to specify a state. Here, state equals Texas. And for the 5-year ACS, which is the default, you need to specify, the default will be the most recent ACS that we have, which is for the 5-year ACS, 2017 to 21. And the year for the 5-year ACS will be the end of that period. So for those of you following along, if you'd like to run this code, this is how I'm going to be doing it today. You see this little clipboard in the upper right. You can click and that will copy the code to your clipboard. I can then go down, I can pull up our studio here, and I can paste that code. Inside our studio, what I will do is then highlight that code. And the step I've done prior to this is I've created a new R script by clicking this drop-down menu and choosing R script. I highlight the code and then I click run, and that is going to execute the code. And so what that does is it communicates with the Census Application Programming Interface, or API, and it assigns the result of what I asked for, which is median household income data at the census tract level for Texas. It assigns that here to an object named median income, and it gets me back data. And so looking back here to the result, and we can take a look at it in the slides or take a look at it in our studio as well, but we get back 5 columns: a GeoID, a name, a variable, an estimate, and a margin of error by default. And so going back to our studio here, we can look at this a little bit closer. Your GeoID is going to be a unique code that identifies a specific geographic location among all other locations in the United States. So for census tracts, we have 11 characters. The first 2 represent the state, that's Texas. The next 3 represent the county, which is Anderson County, Texas. And then the next 6 uniquely represent a census tract within that county. We then have the name of the county, the name of the census tract, or the name of the geography in the name column. The variable is going to be your census variable ID. And then we have an estimate characterized by a margin of error. And the margin of error is in the MOE column, and by default represents a 90% confidence level around that estimate. So we're 90% sure that the true point estimate of median household income is somewhere plus or minus $9,100, around $61,325 for this census tract. You can roughly interpret it in that way. So those are the basics of ACS data. We can jump back here to the slides and keep moving through. 1-year ACS data requires a modification to get. So your call is to get ACS is still going to look fairly similar. You'll use get ACS, specify a geography. Here I'm using place, which is going to be an incorporated city or a census designated place. I'm specifying a state. I'm grabbing median household income again. But notably, I'm doing a couple things. I'm specifying year equals 2022. The default year for get ACS is still 2021. So you have to explicitly request 2022 data with year equals 2022. That will remain the case until the 5-year ACS data for 2018 to 2022 are released in December of this year. I will then update tidycensus. The default will become 2022. That is always when I do the updating every year. You'll also need to specify survey equals ACS1. The default is survey equals ACS5, but we can get 1-year ACS data with the argument survey equals ACS1. That will give us back data, in this case for places in Texas, from the 1-year American Community Survey. So we can go ahead and try that out and jump back here to our studio. And I'll paste that code in. And I'm going to go ahead and run this code. And I get back only 64 places. Now, a couple of things that I did want to show you. What I did was I printed out. I can do median income 1 year, and we see I get the results back. But again, it's only for the largest cities in Texas. I can also click on this object in the environment pane here, and I get an interactive variables browser that allows me to sort my data in ascending and descending order. But I live in Texas. Texas is a very large state. It certainly has more than 64 cities. What this refers to is we get data back in the 1-year ACS only for places or any location with a population of 65,000 and greater, which means we can do analytics here on the largest locations in the US, but not all locations. And so that might make you say, well, should I use 1-year ACS data or not? It's that depends. And I want to talk through this particular use case as we go. So let's spend some time thinking through best practices for working with the 2022 one-year ACS. Because as we've already seen, there are significant benefits to getting very, very recent data. But there are also potentially some drawbacks. It doesn't cover every location because it needs at least 65,000 people to be reported. And given that it's only based on a one-year survey, there might be more uncertainty associated with those estimates. So let's think through some of the limitations of the one-year American Community Survey. We talked about the major limitation. You only get ACS data for geographies of population 65,000 and greater. What does this mean? Well, for one, there are 3,221 counties or county equivalents in the United States. You can only get data on 848 of those counties in the one-year American Community Survey for 2022. Sometimes counties, let's say or places, if they grow in population, they will surpass that threshold. So maybe we couldn't get that data in 2019 and now we can get it. But again, you have to meet that threshold. And so if you don't, you're not going to have that information. And so 848 of 3,221, we're only talking about maybe a quarter, right around a quarter of counties in the United States. Now, they are going to be your largest counties, but we're omitting a significant number. Census designated places or incorporated cities and towns, it's much more extreme. We only have 646 such places that have a population of 65,000 and greater in the United States. There are 31,908 total cities or census designated places. And so yes, 646, you're still going to get your data for your New York's or your Dallas or your Chicago, or indeed a lot of other places, but you might have small suburbs within a metro. You won't get data for that. Or you might have pretty important towns rural towns within a region that are population hubs of 30,000 people. You won't have data for that either. And so there are limitations, and you need to think this through when developing your strategies for analyzing the 2022 data. You also won't get data for a number of geographies. So I will frequently get this question. People will ask, I'm trying to get census tract data from the one-year ACS. Why can't I get it? The reason is the one-year ACS is not delivered at the census tract level. Census tracts or census geographies with about 4,000 people on average, they're not ever going to exceed 65,000 people. Same thing goes for even smaller geographies like census block groups. So if you want to get granular, you're going to need to look at counties, you're going to need to look at places. I'm going to show you some other tips as well in just a moment. I get a lot of people who want one-year data for zip codes, zip code tabulation areas. And again, zip code tabulation areas are not available. There are a small number of ZICTAs that have a population greater than 65,000, but the ZICTA geography is not available in the one-year ACS. And so there are limitations that you need to be mindful of. And so you might need to reach for the 5-year ACS data to get the geographic granularity that you want. How do you find variables? I see a question in the Q&A looking at, does it matter where the variables are? Subject tables, detailed tables. So that's a great question. You might not know what those different tables are. So experienced users of tidycensus will know how to look up variables. You'll use the load variables command, and you'll specify year and a data set, and that will grab variables and variable IDs for a given geography. So something that I'm going to be looking at is maybe language speakers and getting data back on that. And so I might use load variables, and I can jump back here to our studio and jump back to my script. And I can say something like vars is load variables. This out. 2022 ACS1. So I can go ahead and run that. And what it's going to do is communicate with the census website and pull in a data set of variables called vars. There are 36,607 such variables in the 2022 ACS, so there's a lot for me to browse. What I tend to recommend is using this little search box to filter down. So if I'm interested in Punjabi speakers, I can search for that and I'll find the code for it very, very quickly. If I want something that's a little bit more general, like income, I'm going to need to do some additional work because there are 6,368 entries that have income in it somewhere. I can also combine this search box with this little filter button. Maybe I want to filter on the label column and type in median. And now I've filtered down to only 124 entries that cover median income, and I can hopefully find the right one that I need. The code that you pass to the variables command, that's in this name column. And so that's what you want to copy over. There's the question about the data profile or the subject tables. So if you want to look up variables, say from the data profile, which the data profile is pretty great because it gives you pre-tabulated estimates with appropriate denominators. I'll show you. So I'm going to create an object named vars profile at load variables 2022 ACS1/profile. So I'll append /profile to the end here. I run that through. It loads very quickly because I'm only pulling down 1,300 variables. And as you can see here, you get a number of other variables. You can kind of hover your cursor over and see what these are, where we have in many cases, when appropriate, both an estimate and then a percentage that's been calculated with an appropriate denominator. So if, let's say I want the percent of the population with a bachelor's degree and I don't want to compute that myself, I can grab either this variable for percent where their highest degree of educational attainment is a bachelor's degree, or this variable, which is the percentage who have received a bachelor's degree or a higher degree. And you'll notice here is population 25 years and over. So this is computed relative to the population 25 years and over, which is the population for which educational attainment is tabulated. So I don't need to put the work in now to figure out what's the appropriate denominator. How do I go and calculate that? I can use the data profile to pre-calculate that for me. And the nice thing about what tidycensus does is it allows us to just put in a variable ID, and then tidycensus will go and grab that data from the appropriate data set. So you don't need to specify survey equals ACS1/profile. You don't need to do that. We handle that for you internally. So that's a little bit kind of nuts and bolts of how you find variables. Let's talk about some of those limitations of the one-year ACS and engage with that. So you're going to encounter some data issues in the one-year ACS that you may not encounter in the five-year ACS or will be less pronounced. For example, some values available in the five-year ACS may not be available in the corresponding one-year ACS tables. And the reason why this is the case is Census Bureau will suppress estimates that they can't be confident in. And given that they have a larger sample size to draw from in the five-year ACS, they're going to be more confident in those estimates in the five-year ACS than in the one-year ACS. And so even if those estimates are available, they're likely to have a larger margin of error. So this is something to be mindful of. As an analyst, because people ask me this all the time, well, how do I decide then? Should I use the five-year ACS or should I use the one-year ACS? What is the difference? What should I do? And I say, well, you know, it's not the best answer, but it depends. It depends on whether you prioritize certainty versus whether you prioritize recency in the work that you're doing. If you prioritize recency, and you need the most recent data, you don't want that lag back to, say, 2018, go with the one-year ACS. You're going to have more uncertainty in your estimates, but you're going to have more up-to-date data. If you're uncomfortable with the lack of certainty in the one-year ACS, or maybe your data are incomplete in the one-year ACS, then you're going to want to go to the five-year ACS. And certainly if you need small areas, the five-year ACS will be the way to go. But it's often a judgment call based on the topic that you're analyzing and the goals of your project. So let's take a look at this for Punjabi speakers by state. I can grab that information here from the one-year ACS, and you'll see what result prints out. Let's go ahead and try running this over in our studio. I'm going to copy this code over, and I'm going to run it and just see what I get back. You'll notice that for several states, if I want information on how many Punjabi speakers are in that state, I get NA, which means the estimate is being suppressed, likely because of uncertainty or instability in that estimate. So Alabama, I have 666 Punjabi speakers with a pretty large margin of error around that estimate of 556. Alaska, Arkansas, DC, those estimates are small enough that I'm not getting data back on Punjabi speakers. For larger states like California that are going to have a larger Punjabi speaking population, then you're going to get a more robust estimate that you can work with, but this is something that you need to be mindful of. And so we can take a look at this data then, going back here from the 5-year ACS. And we don't have 2022 5-year ACS data yet, but we can look at it from last year's data from 2021. And if we run that code through, we'll see something fairly different. We get estimates back for every state. We have a larger sample size to draw from. Alaska, it's still fuzzy. The margin of error exceeds the estimate. So we're still not very confident in what that actual point estimate is, but we are getting data back for every state. The thing is, if we look at it, you'll see, and we'll kind of be able to compare the two, you'll notice that the margin of error around the estimates for the corresponding states is much larger than it is it's much larger in the 1-year ACS than it is in the 5-year ACS. So Alabama, 666 plus or minus 556, whereas in the 5-year ACS, it's 507 plus or minus 248. So this suggests that probably we're seeing some growth in the Punjabi speaking population in Alabama, but there is still going to be uncertainty around that. It's difficult to kind of clearly say yes or no. So just a few things to keep in mind. What about mapping? I'm a geographer, spatial data scientist. I love mapping. I want to map everything. I got into data analytics through mapping. But I'm skeptical of mapping 1-year ACS data. So if you use tidycensus and you're not using the feature geometry equals true, you need to start using it today. It's one line of code to deal with that entire painful process of retrieving spatial data, joining it to your census data, and getting it ready to go for visualization and spatial analytics. So geometry equals true is great, but for 1-year ACS, it's limiting because, as we've discussed, we only have data like at the county level for a quarter of counties. So what do we do with that? And so when you're trying to map 1-year ACS data below the state level, you'll have complete data for states generally speaking, but below the state level, you're going to have gaps. And I'm not a huge fan of making maps with gaps, especially when they are data gaps. So let's take a look at it. We're going to grab percentage of the population age 25 and up with a bachelor's degree or higher for counties in Texas from the 2022 1-year ACS. We'll jump back here to our studio and try that out. I pull down that data. I'm able to kind of go through and you'll notice that we're downloading the geometry from the census website. I tend to recommend using this option. Options Tigris use cache equals true. That's going to build a local cache of census shapefiles that you can draw from in future uses. And that will speed things up quite significantly, especially if you have slower internet connections. So I'm pulling down this county's shapefile right now. Looks like the download completed. And you'll notice that my Texas education only has 55 observations in it. There are 254 counties in Texas. So I'm leaving out about 200 counties. You'll see this on the next slide, but I really like the map view package for mapping. So I'm going to open the map view package and bring it in with library map view, and I'm going to type map view tx education, and I'll specify a z call, which will be my ACS estimate. Let's take a look at the map here. So we pull this in, and we look at this map, and when we first look at it, we might say, did something go wrong? Is map view not working? No. We have much of rural Texas missing because we're leaving out every county that has a population under 65,000. And so for, say, the Dallas-Fort Worth region, all of those counties are relatively large, so we can still make some comparisons here. Collin County has a higher level of educational attainment than, say, Dallas and Tarrant counties do. But in other cases, you're dealing with considerable sparsity. And even in the Houston area, we're leaving some locations out. So this is something to be mindful of. I don't personally like maps like this, especially choropleth maps with sparsity. And we'll be talking about this a little bit more as we move through the examples. But you might say, well, what do I do? Do I have to turn to the 5-year ACS data? Or is there some alternative solution? My favorite solution is using public use microdata areas, or PUMAs, for geographically consistent substate mapping. Now, what is a PUMA? You may have never heard of that before. A PUMA is a geography defined by the Census Bureau, generally speaking, for microdata. Microdata are individual level survey responses that are anonymized and released for more detailed analysis. The get PUMs function in tidycensus gives you access to those data sets, but also they represent geographies that are redrawn every 10 years, and we just got a new batch of PUMAs in. The 2022 one-year ACS is the first to use the new 2020 PUMA definitions. And what we can do, I'm pulling in here the percentage of the workforce working from home for PUMAs in Washington. PUMAs have between 100,000 and 200,000 residents. So this gives us meaningful substate geographies where we can do some mapping and have the entirety of the United States covered for the one-year ACS. So I'm going to try this out. I'll go ahead and paste that in. And I'm going to map view it. Let's run that through. And look, I have the entire state. I'm not leaving anywhere out because PUMAs will combine counties when counties are below that kind of 100,000 person threshold. But within a region, I can actually see now meaningful differences in work from home. In Seattle, the core of Seattle, work from home is very, very high. You go out more to the Renton and Kent areas, work from home is very, very low. And you can do some analytics around that and have complete representation of an area. So if this is an issue, using the PUMA, I've found to be a really nice option. Additionally, and I'm not going to run this code, but I just do want to show it because I want to get to the next bit. If you work in Connecticut or in the Northeast, you know, but you may not know this otherwise, that Connecticut changed their counties. And counties aren't as meaningful in the Northeast as they are in other parts of the country. But Connecticut did away with its old census geographies and introduced planning regions that they are using as county equivalents. So the 2022 one-year ACS is the first ACS data set to include these new planning regions. So you need to know about this. If you're ever making a map and you don't see Connecticut showing up, this is likely the issue. So we can grab this information for Connecticut. We get all of Connecticut for these planning regions, but we're looking at median household income. I can click and we get that data back for the new planning regions of Connecticut. A few other things, and then I want to move on to the next data set. A few notes for time series analysis with the one-year ACS. So I saw a question about this as well. Like, variables in the data profile and subject table change over time. You do need to be aware of this. And so typically you'll go through and look at load variables and just take a look. but new variables are often added, some variables are removed, and then the codes can change. And so if you're iterating through and pulling iteratively, say in a loop using lapply or using map from the per package, be very careful because you might be pulling different data from the data profile. You'll need to watch out for the Connecticut issue and changing geographies, and also be mindful that the 2020 one-year ACS, because of the pandemic, was not released. So your time series can break if you're trying to pull data for 2020. All right, so let's go ahead and move on to the other data set that we're going to be covering today, which is the detailed DHC-A file. And the detailed DHC-A file, or demographic and housing characteristics A file, corresponds to the 2020 decennial US Census and is now supported in tidycensus version 1.5. It gives us population results by sex and age, but importantly, broken out for thousands of racial and ethnic groups. And so if you're doing analytics around different racial and ethnic groups, this is a great place to look. It has some serious limitations that I've tried to bake into tidycensus. It took me some time to design the API around this because it's a different kind of data set than what we're used to. The Census Bureau uses something called an adaptive design for this data set, which we aren't accustomed to typically working with other census data sets. It means that if a given group for a given geography meets a given population threshold, their data will be available in a more detailed table. But if it doesn't meet that population threshold, the data will be available in a less detailed table. But the less detailed tables, even though they look like aggregations of the more detailed tables, are considered distinct in the DHC-A file, which means that you might try to grab data for your geography, for your group, for a given table, and you'll get an error because that data is not there. You have to go to the more detailed table. And so this can be really confusing. So I've tried to bake it, and I'm going to show you some helpers in tidycensus to help you deal with that. Because just going in, if you're going, hitting the API without tidycensus, you might struggle with that a little bit. Additionally, there's considerable sparsity in the data, and the sparsity isn't consistent. And so you might be trying to pull data on one group at the census tract level, and you get all the census tracts in your region. And then you go to pull from another group, and you don't get any data back. Or you might get only a handful of census tracts. That can be very confusing. And that's because it's all about, meeting these different thresholds, which we'll talk about in a little bit. I've tried to provide some helpers in tidycensus to help you with that, but it still is not entirely easy. So, decennial census data in tidycensus, typically we use the get decennial function. This is pulling from the regular DHC file. So I'm not going to run this code today. You're welcome to try it. It's for Bexar County, Texas, total population. If you want to take a look at my workshops, please do. My recorded workshops are great for diving into the regular DHC data, the workshops I gave this summer. But you can give this a shot. Get decennial is the function that you want. To use the DHC-A file in tidycensus, there's some differences. You'll query with the argument some file equals DDHC-A. So that's what you need. You have to put that in to grab from this file. You also have to specify a population group with the argument pop_group. The reason why this is you can't grab total population from this file. And so if you were just going in by default, you might get data back that is unexpected. So you have to specify a population group, which takes a population group code. This can be confusing because what is your population group code? Well, I'm going to show you some helpers for doing that. If you do pop group equals all, you'll query for all groups, and you'll get all the groups back that are available for your chosen geography. If you set pop group label equals true, you'll get an informative label for those groups as well, which can be very, very helpful. And load variables works as well. Feel free to try it out. So let's take a look at something. Let's look at the state level for Minnesota. We'll grab total population, and the code for that from the DHC-A file is T01001_001N. We pull for Minnesota in 2020. And we're going to specify pop group equals all and pop group label equals true. So let's go ahead and fetch that data, jump back to RStudio and try it out. So we pull that down. We're using the detailed DHC-A file. Take just a moment to pull that data in. We get this error. We get this warning message about differential privacy. I'm going to cover that toward the end of the webinar. So let's take a look at our population groups. So we got back a little under 3,000 groups that are tabulated, and you can see we have a GeoID and name, and then we have two new columns that aren't typical of Get Decennial. We have pop group, which shows that 4-digit code representing the population group, and then we have pop group label, which gives me an informative label because I set pop group label equals true, gives me an informative label for that. You'll notice in some cases like Andorrans, we don't have enough data to report that back. In other cases, European alone, in Minnesota, that population is pretty large from an ethnic standpoint, over 3 million. And then we can drill down and get all sorts of different demographic groups. So you'll get alone and then alone and in combination. There are limits to this that we will be talking about, but you can kind of go through and take a look. So the Somali population is very, very large. We're going to explore that in Minnesota in just a little bit, little under 90,000. And so if I wanted to query kind of more for Somali population, I could grab a specific code, or I might be interested in Somali alone or in any combination. So we have 91,000. So if you're Somali alone or in any combination, you'll pull the pop group equals 1325. So that's the basics of working with the DHC-A data. And so jumping back here to the slides, I have a few more things I want to cover because the DDHC data can be a little tricky. So here's, printing out that result. For one, how do you figure out what the population groups are? Well, you can do pop group equals all and get back that data, or you can use this function get pop groups. We can try that out and see how it works. This is a brand new function. Jump over to RStudio and put that into the script here. We're assigning it to an object named available groups. And I can open up my available groups and now I can browse through. And this can just be a little, helper that I can use to figure out the code that I need to supply. It's important to think through and understand sparsity in the file, however. So I mentioned before that the DDHC-A file uses an adaptive design that makes certain tables available only for specific geographies. And if we read through the documentation, which I link later in the slides, you can read through this. So for detailed groups, you only get total count if there's between 0 and 499 people within that group for nation and state, but it's different for sub-state and then American Indian and Alaska Native areas. And so for the sex by age, for 4 category, 9 category, and 23 category tables, that varies based on the location. And so that is something to be mindful of. And so with this in mind, you might run some code like this. Here I'm pulling Somalis alone or in combination for Hennepin County, Minnesota. I'm trying to pull from this table, T02001, and I get this error message. So I'll show you what that looks like over on the R side. I try to pull, it's going to communicate, and then I get this big error message that explains the DDHC file uses an adaptive design where data availability varies by geography and by population group. So you can look at the tech documentation from this link, but I've also written a new function called check DDHC-A groups. And I'll pull that from the slides here. This is a function that what it tries to do is it scans the DDHC-A files for you for a given geography and group combination. And so if I jump back here and try that out, I can check and see what data I can get. So it's going to check on my table availability. And it tells me the following tables are available for your selection: T01001 and T02003. So I needed to pull from a different table to get my data back. So if I go back up here, I was pulling from the wrong table. So if I change this to 3 instead of 1, I get my data back. This can be confusing. And so hopefully some of these helper functions are going to help you out with that. What about mapping? We all love to make maps, but is it a good idea to map DHC-A data? Given the data sparsity, should you make a map? I don't like mapping geographically sparse data. If you have geographically sparse data, in my opinion, you often want to go for a different visualization type. But if you are careful about your visualization design and you think through the data limitations, I think some maps can make sense. So a good example of that is, let's say we want to map out the Somali population by census tract in Minneapolis. So we'll do Hennepin County, where Minneapolis is located. This code will get us the data we need. Geography equals tract, we pull total population. The population group is Somali alone or in any combination. We'll grab geometry equals true to get those geometries, pulling from the new DHC-A file. So I'm going to copy that over, jump back here to RStudio, and paste that into my script. I'm going to run it. I pull that data down, grab the geometry, and then I'm going to try to map view it. So I'm going to do map view, Hennepin Somali, zcall equals value. You'll notice I get geographical sparsity. This is not all of Hennepin County. I have holes in the city of Minneapolis where we don't have Somali populations reported. And then I have holes especially kind of out here on the outside. So this is like the one-year ACS. You know, there just is no data that's being sent back by the Census API here. And so we have that sparsity. I don't care for choropleth maps with sparsity. Personally, I like choropleth maps that fill out a region. The areas with the greatest concentration of the Somali population, say this area here, where you have those riverside towers, for those of you who know Minneapolis, you get data back for that. But for many other locations, say in Southwest Minneapolis and Minnetonka, you're not getting data back. And so what do you do if you want to make a map of the data? Well, think carefully about how you represent it, maybe represent it in a way that makes more sense given the data limitations. There might be other map types like graduated symbol maps or dot density maps that will work a little bit better. And tidycensus, if you don't know about it, has a function called as.density that allows you to convert data aggregated to polygons to points within those polygons relative to some dots to data ratio. And so for detailed groups like the Somali population at the tract level, if there are fewer than 22 people, Census will suppress that and they won't deliver that data back. So we could specify an as.density. You can specify the number of people represented by each dot. And so if we specify something above 22, then we're baking in that uncertainty into our data generating process and representing something we can be a little bit more confident in, where the empty areas are not just there are no people there, but it's just that they don't meet that threshold. So trying this out, and you can go ahead and try to run this code, and I'm going to copy that over and run it over on the R side just to show you. Try running this code. It'll go pretty fast. We generate the dots, and now we have an interactive dot density map showing the distribution of the Somali population in Hennepin County. Obviously, there is a Somali population over here in St. Paul, but we're omitting that for the moment. And so we see that concentration in kind of South Minneapolis pretty strongly and in North Minneapolis. And we see the geography of the Somali population in the suburbs as well. And this is baking in that uncertainty. And so a few final takeaways about the DHC-A file. Jump back here. and some notes on differential privacy. So census uses differential privacy to preserve confidentiality through noise infusion and makes some traditional census analyses in the detailed DHC-A file impossible. For example, when census acknowledges this, some groups within a group hierarchy may not sum to their parent group. And this can feel confusing. You're used to that, but this is a new reality for us working with decennial data. Small counts will be suppressed, which we discussed. For detailed groups, the threshold is 22. I do link in the slides here to the documentation, which I encourage you to read. All right, so, well, thank you so much for spending the hour with me and learning about these new features. I hope you enjoy trying them out. Just to kind of answer a couple questions that are going to be I think significant. I won't have time to answer every question. One, this is super significant. Jay Maxwell asks, will the Census API be turned off if the government shuts down? Probably yes. It's not an answer that any of us want to hear, certainly. You know, I make a living off of the Census API personally, and so I am very concerned about that. But the last time that we had an extended government shutdown, the Census website went offline entirely. That means no geometries from Tigris. That means no data from tidycensus. I'm going to paste into the chat where you want to look for census data needs in the immediate term. It's called NHGIS. And I'm pasting that into the chat. It's the National Historical Geographic Information System. That's where you want to go to get your data. You can download it. There is an R package that helps you work with it. I have a couple sections in my book about it. Chapter 11 of my book, if you want to get started. It's based at the University of Minnesota, which is where I did my PhD. So I know a lot of the people on that project that can vouch for it. That's what you want to look to. Hopefully, we won't have an extended government shutdown, but in all likelihood, we will be losing access to those data resources until the government comes back. Got a couple questions from Chuck. He'd like some discussion of the CD118 file. I don't have a ton of time for that, but tidycensus 1.5 has partial support for the CD118 file. So if you do sum file equals CD118, you can pull down data for the brand new congressional districts. I don't have geometry support for it yet because census is yet to deliver those shape files in a format that Tigris can readily work with. So you can't do that just yet, but that's coming. You can get CD118 without geometry right now. Chuck also asked, can you supply a vector of population groups? As of right now, you cannot. The reason why this is because you can't supply multiple population groups to the Census API, a comma-separated list. Potentially in the future, I could enable that in tidycensus. I have not developed that yet. So you'll either need to pull one at a time, or you'll need to set up your own iterator using the per package, or use all and then just use filter in dplyr to grab the data you need. One other question about Puma release schedule from Travis Deese. Important distinction. I think you're talking about the PUMS data coming out on October 19th. The data that I'm pulling is the geography at which the PUMS data are basically identified. So public use microdata areas, those geographies, they're typically used for geography in microdata, but we can also tabulate census and ACS data. Typically ACS data, honestly. They've been suppressing it from the census, but you can tabulate ACS data at the Puma level, and that's what we're doing. So last question, what do you do if the MOE is greater than the estimate itself? It's a hard question to answer. I mean, you know, in some cases, if you need better certainty than that, you know, you could bake that in and code that as, you know, an unstable estimate to be sure, or, you know, or, you know, if the 5-year estimate is there or a possibility. It's one of those things that's unfortunately a bit of a judgment call. So thank you so much for your time. I'm really glad that you took the time out of your busy schedules to learn about some of these new features. Just kind of jumping back here to the beginning. It would be fantastic to see as many of you as possible at the GIS workshop series in October. So a couple great workshops. Discount code DDHC-A, 25% off those workshops, 25% off the recorded workshops as well in the 2020 census. Definitely appreciate you all supporting my work, and best of luck working with the new data sets. Fingers crossed we avoid a government shutdown so you can play around with it for more than just the next couple of days. But thanks again, and keep your eye out. I'll be giving more webinars like this in the future.